Hello everyone, welcome back to my channel Chem with Dishika, and here this time we are having the concept of aldol condensation reaction. So I think all of you must be aware about the reactions that happens in carbonyl compounds. And what are carbonyl compounds? One of the most major reaction that we discuss over here is the aldol condensation reaction, and this becomes the favorite topic of our competitive exams like JEE and NEET. So in this video we are going to learn about aldol condensation. What are the prerequisites, what are the mechanism, what are the related questions. So keep watching this video and we'll discuss all of these concepts. So let us start with the video part. The very first thing that we have over here is the prerequisite for aldol condensation reaction. Firstly, aldol. If we break up this word, that is aldol, what do we mean by aldol? So this al comes from the word that is aldehyde, and this all words come from the alcohol part. So basically aldehyde and alcohol combine together to form aldol. So just like we form the mixture of two names, right? So this is in the trend, the latest trend, we form hashtags. So just similar to that, we have aldol over here. So if you break up this word, this ald comes from aldehyde and ol comes from alcohol. Now why aldol? Because the product that we are getting over here is a mixture of aldehyde and alcohol. So basically your product contains both the functional groups, that is aldehyde and alcohol. That is why the name for this reaction is aldol reaction. Now here the point to be noted is that here two type of name reaction you will come across, that is the aldol reaction and the aldol condensation reaction. So what is a condensation reaction in general? Condensation means loss of water. So here if you are giving the conditions for condensation, then it will be called as the aldol condensation reaction. Otherwise you will be calling it as only the aldol reaction when you stop at your product, that is aldol product. So we learn each one of these, what is aldol condensation. But before that, let us first see which molecules undergo this reaction, right? All of the molecules do not undergo this reaction. There is some prerequisites, some necessities that are required to fulfill in order to complete this reaction. So firstly, here we learn the concept of alpha hydrogen. So what exactly is an alpha hydrogen? First we need to see that, and only those compounds, those carbonyl compounds, aldehydes or ketones that are having at least one alpha hydrogen, they are able to show aldol condensation reaction in the presence of. So basically here the reagent that we require is a base. So that base is your diluted base, like alkali is basically your base, and that can be your dilute NaOH, Na2CO3 or barium hydroxide. So these are the bases. So first let us try to understand what is an alpha hydrogen. So basically here, if you will see the hydrogen that is attached adjacent to the carbonyl group. So basically here, let me just show you this slide here. So to understand what is an alpha hydrogen, we have all these examples. Basically just identify the functional group. So this is your functional group here, that is your aldehyde. Now just go to the carbon that is directly attached to this functional group. So this carbon is directly attached to the functional group, and that is why I'll call it as the alpha carbon. And similarly, if I have to identify what is an alpha hydrogen, the hydrogen that is attached to this alpha carbon is called as the alpha hydrogen. So these alpha hydrogens are very important. They basically undergo the reaction, the aldol reaction. So just to have a clearer view on this alpha hydrogen, we have some more examples. Here if you will see, this ketonic functional group is present. So there are two carbons present on both sides of this functional groups. So I'll call it as alpha carbon and I'll call this as alpha dash carbon. But here in total, if I have to count how many alpha hydrogens are present, then here 2 alpha hydrogens from this side and 2 alpha hydrogens from this side. So in total there are 4 alpha hydrogens which are present. Okay, so both the hydrogens from both sides you have to count the hydrogens. Now if I ask you that here in this case how many hydrogens are you able to encounter? So if you will see here your formaldehyde structure is given. So if you will see the functional group that is present is of a aldehyde. So this is basically your aldehyde. There is no carbon attached to this aldehyde, right? So no alpha carbon is present and hence no alpha hydrogen will be there. So here 0 alpha hydrogen is present, which means that it is not going to undergo aldol reaction. Similarly, if I ask you the fourth case over here, you'll see that here CHO group. So if you'll expand the CHO group, you'll be able to write it like this. So here if you see the structure, then this carbon is basically your functional group, that is your aldehyde. So this is the alpha carbon. So although there is a alpha carbon present, but there is no hydrogen that is attached because carbon can only make 4 bonds, right? So here carbon has already made up 4 bonds. First bond, second bond, third bond and fourth bond. So there is no vacant valency, therefore there is no hydrogen that is present at this position. So therefore here no alpha hydrogens are present. So this will also not undergo the aldol reaction. Alright, so firstly we have to identify what is an alpha hydrogen. Once you have got your alpha hydrogen, you are sure that now you are going to, the molecule is going to undergo the aldol reaction. So now when we have learned the concept of alpha hydrogen, let us now move on to our aldol reaction. How actually this takes place? So here what happens is, as I told you, this hydrogen is acidic in nature. Now there is a concept of acidity. Okay, so basically these alpha hydrogens are acidic in nature. So in your NCRT, this is also one of the most favorite questions of CBSE board, that why these alpha hydrogens are acidic in nature. So to characterize a substance nature, whether it is acidic, whether it is basic, what is the prerequisite? We just remove this hydrogen, we form the intermediate that is formed and we look at the stability. So after the hydrogen is removed, a negative charge would be generated and this negative charge would be further stabilized by resonance because here double bond O is present. So this indicates that these hydrogens are acidic in nature. Why? Because the electron density around this hydrogen decreased due to the minus I effect. You can also relate it with the minus I effect, that C double bond O groups in general are basically the electron withdrawing groups. So this is your inductive effect. It is due to which they pull electrons towards themselves, and hence the negative charge that is generated after the removal of this hydrogen becomes stabilized. So if the carbon ion that is formed is stable, then we say that they are acidic in nature. So now we have learned that these alpha hydrogens are basically responsible for reaction due to their acidic nature. Okay, so this carbonyl group is electron withdrawing and shows minus I effect. Now if I look at the mechanism, we have learned what is the substrate that we are going to take. We are going to take any substrate that is containing alpha hydrogen and carbonyl compounds, and the reagent that we are going to take is some dilute base, and that base can be any base. Okay, so now see the reaction, how does it takes place. So in this mechanism, what happens is, let's suppose this B indicates that it is a base. So this base, what is the property of any general base? It is responsible for the abstraction of protons. So this base will come up and abstract the acidic hydrogen that is present over here, that is the alpha hydrogen. This is your alpha carbon, and this base will abstract the alpha hydrogen, and this bond will be shifted towards this carbon, indicating that a carbanion is formed. Okay, and base will pair up with hydrogen to form BH. It will neutralize itself. Now you know that you have studied resonance. This negative charge can resonate with this oxygen, and you can draw the other resonating structure for it as shown over here. Okay, so this is the resonating structure which says made us look at the stability. Okay, now what will happen, we'll take another mole of the same compound that we have taken initially, for which we have generated this carbanion. Now you know that in chemistry in general, electrophile loves to interact with a nucleophile, or in general a positive loves to interact with a negative charge. Similarly, now you have got a nucleophile. Negative charge is electron rich in nature, right? So here you have got your nucleophile. Now you are in search of an electrophile. From where this electrophile is going to come? So look at this substrate that you have taken initially. Here you know that amongst carbon and oxygen, this carbon is electrophilic in nature. It is carrying a del positive charge, and this oxygen is carrying a del negative charge, because we know that oxygen is more electronegative than carbon. So what it will tend to withdraw electrons towards itself, right? So which is why it will be carrying a partial negative charge and carbon will be carrying a partial positive charge. Now in the next step, we know that this can act as an electrophile. So what is going to happen, the negative charge which you have generated over here in this first step will be attacked at this electrophilic carbonyl carbon. So basically the negative charge that you have generated over here will attack at this position, and the electron density will be seen shifting towards oxygen. Okay, so what is going to happen over here, the oxygen, it will be basically your CH3, C, O negative and H. So this O negative is basically abstracting this hydrogen and is becoming CH2COH, CH2COH, and this is the product that you are able to get. So just to avoid confusion, let me remove this, and getting back onto this, what we have is the beta hydroxyaldehyde. Now don't get confused. Here we know that the primary functional group that is present is of a aldehyde. So the carbon present next to it is an alpha carbon, and the carbon present next to this alpha carbon is your beta carbon. Just like you number 1, 2, 3. Similar in chemistry, you number it alpha, beta, gamma to denote the positions with respect to the functional group. So at the beta position, your OH group is present, and while studying the IUPAC nomenclature, we saw that when OH is present as a secondary functional group, then we use the prefix that is hydroxy. So here you will name it as beta hydroxyaldehyde. Now this compound is containing both aldehyde and alcohol, which is why I am calling it as aldol. So this is the reaction that is going to take place. Now why aldol condensation? So here what happens is, this OH and the hydrogen present at the alpha carbon gets eliminated out in the presence of heat. So when it is subjected to heat, this gets out, and all you are left is with alpha beta unsaturated aldehyde, because a double bond is formed between alpha and beta carbon, which is why you are calling it as alpha beta unsaturated aldehyde. Alright, so that's how the reaction takes place, and when only heat is mentioned, you have to eliminate water. Otherwise there is no need to eliminate water. You will stop at the aldol product. Okay, So I hope you understood how this mechanism actually takes place. So there are multiple questions that arise out of this mechanism, like what is the intermediate that is formed. So the intermediate formed here is carbon ion, and this carbon ion needs an electrophile. So you take another similar mole of this compound and treat it as an electrophile this time, and both interact with each other to form a product that is your aldol product. And this aldol product upon heating gives you an alpha beta unsaturated aldehyde. Okay, so now let us have a look at this question. What does it says? So here is a quick question for you. Just pause this video for a second, just try it out, and then we'll look at the solution. Okay, so I think you all must have tried this question at least, and now let us have a look at how to exactly solve this question. So basically, first you need to identify whether the aldol condensation is going to take place for this reagent, for this substrate or not. So you have to identify by looking at the alpha hydrogen. So this is the functional group that I can identify over here is of ketone. So there is one alpha carbon which is present, and there is another alpha carbon which is present. So there are two alpha carbons, and there are 6 alpha hydrogens in total which are present for this substrate, which means that aldol condensation reaction can be carried out. Okay, 2 moles indicate that this will act as a nucleophile and electrophile both. OH minus indicate that this reaction is taking place in the presence of a base, and that is going to give you A, which will be your aldol product, and heat indicates that further the condensation is going to take place. Okay, so let us have a look on how to solve this question. First we have this compound, and I can write it like this. Now since it is a symmetrical ketone, so it is up to you whether you want to remove hydrogen from left hand side or right hand side. You'll get the same product in both the cases. So here OH minus indicates that it is a base, so it will come to abstract the proton, and the electron density will be seen shifting towards this carbon, which means that here now you are able to get CH3 C double bond O CH2 negative. Okay, so this is the carbon ion that you are able to get. Now you know that this can get involved in resonance with the structure, and the further the resonating structure would be shown like O negative double bond CH2. Okay, but you have to make use of this substrate in order to react it with the another mole. So basically this will react CH3 C double bond O CH2 negative. It will react with another mole of the same compound. Since we have taken 2 moles, 1 mole we have utilized in making up of carbon ion, and second mole we are treating it as an electrophile. Okay, so here this negative charge would react on this electrophile, which is del positive and del negative, and the electron density would be seen shifting towards oxygen. Okay, so what is going to happen? CH3 C double bond O CH2 C double bond O. So basically here this will become O negative. This is O negative, and this O negative can get neutralized when it will react with H plus. So basically it will be OH. Here one CH3 and another CH3. So this is the kind of aldol product that you will be able to get in this reaction. Now since here no hydrogen is present, so therefore you can call it as ketone because it is a ketone. So basically here ketone from KET from ketone and ol for alcohol, so that is why you will call it as ketol. Now this will be your A. Okay, this will be your A. Now to identify what is B, heat is given. So basically here you have to carry out the condensation. So how to carry out the condensation? Just remove one hydrogen from this side. You can write it like CHH, and what you can do is you can remove this OH and H, which is water, and when you will remove the water, one double bond will be generated over here. So basically let me just erase this part. So here you have CH3 C double bond O. Okay, so once you remove the H2O part, that is minus H2O, then you will be getting CH3 C double bond O, CH double bond C, CH3 and CH3. So if you'll correctly see it, this is your alpha carbon, this is your beta carbon, right? So a double bond is generated between alpha and beta carbon, which means that here alpha beta unsaturated aldehyde or ketone is generated. So that is going to be your B part. Okay, so this is your A and this is your B. I hope this is clear to you how we have done this. Now we have another reaction related to aldol reaction, which is called as the cross aldol condensation. So in aldol condensation, what we were doing is we were taking the similar moles, right? So in this reaction also what we did was we took 2 moles of the similar compound. First acted as a nucleophile and another one acted as an electrophile. Now in cross aldol condensation, we are going to take 2 different molecules. So here aldehydes are present and both of them are containing alpha carbons, but here we have to look at the possibilities that can be generated out of this. So when the aldol condensation is carried out between 2 different aldehydes or ketones, it is called as the cross aldol condensation, because here the condensation or the aldol reaction is going to take place between 2 different molecules. Now here the question arises, how many products in total we are able to get out of this reaction. First you have identified that it is containing alpha hydrogen and this is also containing alpha hydrogen. Now the reagent you will check is of a base and heat, which means that aldol condensation reaction is going to take place. Now if you look at the possibilities, there will be in total 4 possibilities. Okay, so the 4 possibilities would be the first one would be that a self-aldol reaction would be carried out. So basically this molecule can react with another molecule of itself to get a simple aldol condensation product, which is CH3 CH double bond CHO, which is but2-enol. Similarly, this can get under self-aldol condensation reaction. It can react with itself and can form 2-methyl pent2-enol. Okay. Now, the other possibility arises that the negative charge is formed from this carbon ion and the positive charge electrophile you take it for this carbon. Okay. So basically here once this can act as a nucleophile and another time this can act as a nucleophile. So depending on these two you will be able to get 2 products, and in total including the self-aldol products and the cross-aldol products, in total you will be able to get 4 products. Okay, so let us have a look at what are the 4 different kind of products and how they are formed. So basically here talking about the self-aldol products, this molecule will react with itself in order to form this aldol product, which upon heating will give me this product. Similarly, if I take another molecule, that is this propanol, so propanol would react with another mole of itself to form this compound, which is your aldol product, and next is the aldol condensation product. So I think you will be able to make these 2 products out of this. Talking about crossed aldol products, what can happen is here that once you create the carbon ion for this CH2 negative, so basically what you are doing is you are taking 1 hydrogen out of this, forming a carbon ion, and this carbon ion is basically attacking on this ketone, right? And this electron density is getting shifted. That's how you are able to get this product. So the other possibility other way around is that here the negative charge you are generating out of this carbon ion and you are taking this as a electrophile, and you will be able to get this as the product in another case. So once the carbon ion is generated from this molecule, and second the carbon ion is generated from this molecule. So let me just correct over here. The negative charge in this case would be formed from here, this carbon. So this OH negative would attack over here at this position, and this will attack on this carbonyl carbon, and the electron density would be seen shifting towards this oxygen. So that's how the reaction will be carried out. Once the negative charge on this and another time the negative charge on this molecule. Okay, so in total there will be 4 products. So here is a quick question for you. You have to tell me the major product that will be formed out of this reaction. How is it going to be? So I believe you all must have tried this question, and now let us have a look at it. So just at the beginning of this lesson, I told you that in order to carry out the aldol condensation reaction, you have to see which molecule has basically alpha hydrogen. So here there is alpha carbon which is present, but there is no hydrogen present at this position. So therefore it has 0 alpha hydrogen, which means that here no carbon ion can be generated, right? Because OH negative would come to abstract the alpha hydrogen. But in the second case, there are 6 alpha hydrogen which are present, right? So what is going to happen over here is that if you write it in this way, then this OH negative would come up and abstract this hydrogen, which in turn would return to this, and you will be able to generate the carbon ion. So once you have your nucleophile, now you are in need of the electrophile. So this can act as an electrophile. How? So basically here I am having a benzene ring to which C double bond O and H is attached. So this negative charge would attack on this carbonyl carbon, and the electron density would be shifting towards it, and you will be getting this as the product. So that will be COH, H, CH2, CO, CH3. So that is going to be the aldol product which is present. Now here, since heat is not mentioned, so therefore you have to stop at here only. In case heat was mentioned, then what you need to do is you just need to eliminate one hydrogen from this. So OH and H will get eliminated out to give you your alpha beta unsaturated product, which is your C double bond CH, that is CH double bond CH CO CH3. So this is your alpha carbon, this is your beta carbon, and that will be your alpha beta unsaturated carbon. So that is going to be the answer for this. In case heat was given, then you have to stop at this. Otherwise, if heat is not mentioned, then you don't have to eliminate water and you have to stop at this only. Alright. So the prerequisite, you have to keep it in mind by identifying the kind of substrate you are looking for, and by identifying the kind of reagent that is given, you will do the aldol reaction. Alright. Now there is a homework for you. This is the question, and basically you have to write all the products that you can make out of the reaction from propanol and butanol. And you have to also state which you are taking as for a nucleophile and which one you are taking it for an electrophile. So in the next session we'll be discussing this solution. Till then, try it out, and in case you find any doubts, you can just feel free to ask me in the comments. I hope you liked this video and this video was useful to you and you understood what exactly is aldol condensation reaction, what are its prerequisites, and how does the reaction takes place. So let's meet up again in the next video session. Till then, happy learning.